This is Dr. Mobeen Sayed with one more episode of Long Story Short with Dr. Bean from the FLCCC platform. So we'll continue our discussion about the slow wave sleep or N3 sleep and the washing away of the metabolites or the waste products in the brain, especially in the context of the Alzheimer's. The basic summary of this talk is the following, that it seems like in Alzheimer's, there is sleep disturbance. About 1/3 of the patients of Alzheimer's have clinically diagnosed sleep disturbances. Although it is also observed that even before the symptoms of Alzheimer appear, patients have sleep disturbances. And more commonly, sleep disturbance of the slow wave sleep, which is the slow wave sleep, is related to washing away and flushing out of the waste products in the brain, including beta amyloids. So if that is the case, then it is possible that the slow wave sleep disruption in patients, in people, can cause the accumulation of beta amyloids, which would in turn cause or be associated with the Alzheimer's disease. Now, Alzheimer's disease itself further causes sleep disturbance as well. So it is kind of a positive feedback loop. So let's look at this discussion. So first, the papers. This is one of the papers, The Sleeping Brain, Harnessing the Power of the Glymphatic System Through Lifestyle Choices. So here, the message once again from the authors is to have appropriate duration of the sleep and good performance of the sleep, and that is how we can at least have a chance to stall or reduce the progression of Alzheimer's or dementias. So here in this paper, this is the segment Sleep and Alzheimer's Disease 3.2.3. That is what I'm going to discuss. However, let me also very quickly share, this is FLCCC. So this is the platform from which this talk is being presented. So if you see here, there are treatment protocols. So I would request you to look at especially the iRecover protocol. There are many other medical evidences and resources and educations available. Then here is one more paper that I want to use today. This is Alzheimer's Research and Therapy. This paper is 2022, March 2022. APOE 4, Alzheimer's Disease, Neuropathology and Sleep Disturbance in Individuals with and Without Dementia. Then here is an article in harvard.edu, Sleep Well and Reduce your risk of dementia and death. So here they have presented a few studies where sleep disturbance or less performant sleep is associated with more likelihood of developing dementia or dying. So these are the paper. The links will be in the description. Let's start with my drawings. So this is just once again the review. And we have been doing this for now, I think this is the third lecture in which we're talking it. So I'm hoping that you are kind of already well aware of this diagram. So here is the arterial side. There is capillary inside here. Around the capillary, there is this perivascular space. In the perivascular space is CSF. Capillary has channels. Remember, these capillaries have tight junctions, so they do not allow the normal substances to come out. So there are specialized channels that selectively pick up things that we need in the brain. Then those substances are mixed with the CSF and then they come out through the aquaporine 4s. And actually there are many kinds of aquaporins, but 4 are more important here in our discussions. And then those fluids, they pass through the interstitial spaces, and these fluids are called now interstitial fluids. And this is a convection current. And then these fluids will then be drained away from the venous sides. Now, same structure on the venous side as well, that there is a venous end through which some substances will get back into the blood, some waste products, some substances. At the same time, around the veins also are the perivascular spaces. These perivascular spaces will collect the bigger metabolites, including beta amyloids and the tau proteins and other big waste product molecules that cannot enter the blood vascular system. So those substances will then pass through the perivascular spaces and eventually through the deep cervical lymph nodes, these will get back towards the venous end. So keep this in mind. And once again, the slow wave sleep is responsible for the most of this convection current to occur, which will wash the brain or flush the waste products. Now, it probably is very clear then that if the slow wave sleep is somehow disturbed, then that will mean the washing away of the beta amyloids and tau proteins and other such proteinaceous materials will become a problem, which in turn, once those materials, they start accumulating here in the interstitial tissue, in the brain tissue, they would cause further disruption of the brain function and the fluid movement, which in turn will cause further aggravation of the problem, leading to dementia, which can then become a cyclical problem. Okay, so we discussed this last time, that glymphatic system and the brain and the N3 sleep. The N3 sleep, which occurs mostly within the 45 minutes of you going to sleep, when the sleep pressure is the highest, that is when the N3 sleep occurs. This has low rhythmic movements or delta sleep patterns during this time, as we discussed last time as well. And that was that delta waves appear. These delta waves are the most dominant in the childhood, but then they starts becoming lesser and lesser as we age. The exact mechanism for why that happens is not clear. Maybe it is related to neurodegeneration. And we knew that some functions of the slow wave sleep, learning, memory, metabolite clearance, this is the most important thing. And then sleep pressure, or how much deeply you are sleeping, is very important. This is also the N3 is an NREM sleep, non-rapid eye movement sleep. And I discussed that all in the last lecture. Now let's go to today's talk. So these studies that I just showed you, they demonstrate that disturbance of sleep patterns and duration is associated with Alzheimer's. Now it is possible that a patient of Alzheimer's have the sleep disturbance because of the Alzheimer's pathology, or sleep disturbance was predated and was one of the contribution towards the Alzheimer pathology, and then both of those pathologies coexisted. Alzheimer's is the most common form of dementia. It is a chronic age-related neurodegenerative disease. The deterioration of memory occurs, language issues occur, inability to take care of self, that occurs. Insomnia and sleep apnea are very common. Sleep issues seem to be contributory to Alzheimer's disease, but a causal link isn't fully established. So we haven't yet found to say that if somebody has a sleep disturbance, then they must have Alzheimer. That causal relationship is not found. However, it is seen that, for example, APOE4 that we'll discuss here today, the presence of the APOE4 enzyme causes sleep disturbance. And then the patients who have APOE4, or people who have APOE4, they have more dementia compared to those who have APOE3. And similarly, people who have homozygous APOE4, that means that all of their alleles are APOE4, and I would discuss that a little more later on, they seem to develop more dementia and more early dementia. And APOE4 is shown to cause sleep disturbances. So maybe it is a sleep disturbance. So I'm getting ahead of myself. Let's just keep looking at this one. So sleep issues may be contributing to Alzheimer's disease. Then Alzheimer's disease itself would cause sleep issues. In the Alzheimer's disease, from the sleep's context, there is shorter sleep time. There is increased awakening. There is increased number of interruptions to sleep. There is worse sleep efficiency compared to the controls. So a person of Alzheimer's disease sleeping and a person without Alzheimer's disease sleeping, the sleep performance and efficiency in controls is better than Alzheimer's disease patient. Sleep is more fragmented. As I said before, there are more awakenings. So sleep is more fragmented. And of course, you have seen this, that N3 is already just 20 to 25% of the sleep. The delta wave sleep, the slow wave sleep, it's just already a smaller chunk. And that is also in the youngsters. As we age, that 20 to 25% of the segment also starts becoming lesser. Now think about it, that on top of that, if there is an additional layer of sleep disturbance, then the chances of N3 become even lesser. And that would mean that slow wave sleep is less. That will mean that metabolic movement, the metabolic waste product removal that occurs during the delta sleep, that would also be impacted, which will mean amyloid betas and taus and other waste products would accumulate, which will mean neuroinflammation would occur, which will mean more neurodegeneration would occur. And this also means that we have to figure out how to sleep better. And I discussed that yesterday. There are many articles on how to make sure that you are getting N3 sleep and how do you sleep better. Maybe as part of this series, I will do one talk entirely on how to sleep better. Now, APOE4. So let's talk about that a little bit. So let me show you some evidence first. Here in this paper, The Sleeping Brain, they say there are genetic links emerging between sleep and Alzheimer's disease. One of the major genetic risk factors for Alzheimer's disease is apolipoprotein E, of which reduced function is associated with sleep apnea, the progression of sleep disturbances, cognitive performance, and sleep deterioration. APOE therefore provides a genetic link between sleep and neurodegenerative diseases, adding to the validity of this relationship. We therefore suggest that sleep and sleep impairment likely play a compelling role in neurodegenerative diseases, in particular in regard to waste removal from the central nervous system. They do say it remains to be demonstrated whether other mechanisms aside from sleep universally impair the process. Now this is one. Then let's see here. Sleep 6 to 8 hours each night. In the first study, researchers at Harvard Medical School studied more than 2,800 individuals ages 65 and older. The study was to examine the relationship between their self-report of sleep characteristics in 2013 and 2014 and their development of dementia and/or death 5 years later. Researchers found that individuals who slept fewer than 5 hours per night were twice as likely to develop dementia and twice as likely to die compared to those who slept 6 to 8 hours per night. Very important thing. So once again, the question in your mind will continue to arise, and that is, how do I sleep better? I did that talk a little yesterday, and I would do one more lecture, but the result of this discussion, my request will be that you seek how do you sleep better. Is it more exercise that you should do? Is it less nap at all during the daytime? Is it warm bath, exercise? Is it a set schedule of sleeping? Is this the environment for sleeping to be more cleaned out? The mobile not to be present, the type of lights to not have blue color in them, and so on. What is it that would help you sleep better? You will have to figure that out, and that will be very, very important for brain health and general well-being of us as we move forward in our age. So here, the takeaway, 5 hours versus 6 to 8 hours, just that much of a difference. This study controlled for demographic characteristics, including age, marital status, race, education, health conditions, and body weight. Then, here is the other one. In the second study, researchers in Europe, including France, UK, Netherlands, and Finland, examined data from almost 8,000 participants from a different study and found that consistently sleeping 6 hours or less at age 50, 60, and 70 was associated with a 30% increase in dementia risk compared to a normal sleep duration of 7 hours. The mean age of dementia diagnosis was 77 years. This study controlled for socio-demographic, behavioral, cardiometabolic, and mental health factors, although most participants were white, better educated, and healthier than the general population. In addition, approximately half of the participants had their sleep duration measured objectively using a wearable accelerometer, a device that tracked their sleep during using body movements, which confirmed the questionnaire data. So this is a little more thorough because they used a device to assess the sleep and sleep's quality. So once again, huge and important takeaway, 6 to 7 hours at least. Now the other study, which I wanted to share today, is about the APOE. So what happens is apolipoprotein E, epsilon, 4, carrier status is an established risk factor for Alzheimer's disease. So what happens is that apolipoprotein E can be of type 3 or 4. The type 3 is actually fine, but those who have allele, that means genes, to make type 4, they have more incidence or higher incidence of dementias. Now, apolipoprotein E4 can in turn be on both alleles. So normally we have sets of genes that make the same proteins. So if both sets, so imagine me, I have one apolipoprotein E3 gene and an E4 gene. So that will be a heterozygous. Or if I have E4 and E4 gene, these will be homozygous. Homozygous E4 have a greater risk. So how great is that risk? Let me show you. Relative to the common E3 allele of apolipoprotein E, the E4 allele is an established risk factor for the development of sporadic and late onset familial Alzheimer's disease. Within predominantly Caucasian population, increasing allele dose is positively associated with AD risk Alzheimer's disease, with E4 heterozygosity conferring an odds ratio of approximately 3. So if there are two heterozygous, 3, and E4, so that previous one, heterozygous, 1 E3 and 1 E4. Just that presence of 1 E4, that means some E4 proteins are made and some E3 proteins are made. Just that causes 3 times more odds ratio of developing Alzheimer's. And if both are E4, then the odds ratio of approximately 14 compared to E3. APOE4 also lowers the age of onset in similarly allele number dependent manner, with one allele advancing onset by 2 to 5 years and 2 by 5 to 10 years. So the question, I think, will be in your mind that, number one, do I have APOE3 or E4? And I think those genetic tests can be done. Secondly, important clue here is this. APOE4's presence is associated with sleep disturbance. So sleep disturbance is a more important and more observable mechanism that we can try to correct. So continuing with this one, I read these couple of paragraphs. Now, mechanism. How does APOE4 cause this sleep disturbance, or does it directly also contribute towards Alzheimer's? So it seems like it can directly cause accumulation of beta amyloids and tau, and I'll explain in a second. And it can indirectly contribute towards Alzheimer or dementia by causing sleep disturbance. Sleep disturbance in turn will cause the slow wave sleep or the N3 sleep or the delta wave sleep to become lesser and lesser, which in turn will cause less metaboloid clearance, which in turn will mean tau proteins and beta amyloids would start accumulating. So let's look at this one. Multiple mechanisms have been proposed through which APOE4 may exert these effects. Apolipoprotein E4 affects amyloid beta metabolism, predisposing to its extracellular deposition and amyloid plaques. Now, this could be through the sleep disturbance or direct, and to more severe cerebral amyloid angiopathy, blood vessel problems. Whilst effect on A beta are hypothesized to represent the dominant pathway, proteolytic APOE4 cleavage. So that is, if you are making APOE4 and if the body and brain is under stress or is during an injury, then APOE4 is broken down. So when the cleavage of APOE4 occurs, resulting from stress or injury, also predisposes to tau hyperphosphorylation and neurofibrillary tangle formations. So APOE4 can indirectly cause sleep disturbance, it can directly cause beta amyloid production, and during stress or injury, it can further also contribute to tau production and to formation of the neurofibrillary tangles. These are all the proteins that are observed, and the tangles are observed during the Alzheimer's. And one result of the tangles is that the neurons start dying. So once again, really important to have good sleep, so that even if there is APOE4 homozygous or heterozygous present, if we take care of our sleep, we can reduce the chances of progressive or faster or accelerated dementia. Multiple studies have also linked APOE4 to sleep disturbance, specifically objective sleep disturbance in healthy older adults, and increased risk of insomnia, obstructive sleep apnea, sleep disorders, breathing in adults and children. Improved sleep was reported to attenuate the negative effect of A4 on incident Alzheimer's disease. This is the most important thing. that even if the genetic predisposition is present, if we take measures, if we do things to improve our sleep, then improved sleep was reported to attenuate the negative effect of E4. Additionally, E4 has been proposed as a mediator of the relationship between sleep and cognitive decline, both obstructive sleep apnea and APOE4 impairing cognitive performance. However, whilst possession of E2 reduces the odds of developing AD, this allele has been linked with increased likelihood of OSA or sleep apnea. Now, sleep disturbance, whilst traditionally associated with established Alzheimer's disease, is detectable prior to the emergence of symptoms. This is very important. That means it is not necessary that during the Alzheimer, the sleep disturbance is because of the Alzheimer. It may also be that originally sleep disturbance led towards Alzheimer. And then when the Alzheimer occurred, then sleep disturbance also got bad, which would further accelerate the progress of Alzheimer's disease. So emergence of symptoms and plays a potentially causative role in Alzheimer's disease pathogenesis. So these are interesting papers to look at. At the end of the day, if I can summarize it, very simple lesson here, and that is better sleep. And better sleep is easy said than done. If I said have better sleep, that doesn't mean you will go and right now have a good sleep. When somebody is going through bad sleep, and I have been through bad sleep during COVID, it is a struggle to be able to sleep better. So you'll have to find ways to sleep better. And so COVID causes severe sleep disturbances. Long COVID causes sleep disturbances. Vaccine injury causes sleep disturbances. Then the pandemic and the scare and the fear and the financial outcomes and the mandates, the psychological outcomes cause sleep disturbances. The financial outcomes cause sleep disturbances. So it's not a go sleep better kind of a message, but we still have to understand at least 7 hours of good sleep with good sleep pressure so that the first 45 to 90 minutes you can get N3, which is slow wave sleep that would clear out the substances. And how do you build good sleep pressure? You are tired. You have not slept during the day, so there is a need to sleep. You're tired, you're sleepy, you want to sleep. That is sleep pressure. So you took a warm bath, you did exercises, you ate appropriately, no coffee in the evening, etc. So you develop sleep pressure that triggers N3 sleep, which is very, very important for, in the long run, also to reduce the chances of AD or stall the AD. With this, thank you very much. I would see you next time with one more topic on the brain health, slow wave sleep, and the glymphatic system. Thank you very much. Bye for now.